The last lesson was focused on finding the binomial factors of a trinomial with the leading coefficient of 1. If those seemed easy, that's because we didn't need to worry about the factors of the degree 2 term, since they were simply x times x. Finding the binomial factors of a trinomial with the leading coefficient other than 1 will be a bit more difficult. There's a few things that need to be kept in mind while looking to expand these. Let's start by writing out what we are working with. Looking at the first part of this example, it would seem like any other binomial product we've learned to multiply with FOIL. However, if you were asked to go backwards and factor that trinomial, you'd find that it's a bit more difficult because the leading coefficient is 2. Instead of starting with the c term as we would previously, we're now going to start with something a bit more interesting. We are going to take the factors of the product of the leading coefficient and the c term, or rather, a times c. What this will do is allow us to find a factor of a times c that will sum up to give us b. So if we take a times c, we will get 2 times 2, which is equal to 4. The factors of 4 are 1 and 4 and 2 and 2. The sums of each of these sets of factors are 5 and 4. Notice that the first set is a factor of a times c and sums up to b. That's our factor. Now, instead of using those two factors as our binomial constants, we're going to use those factors to rewrite our trinomial into 4 terms. 2x squared plus 4x plus x plus 2. Look at the middle 2 terms. They sum up to our original second term, 5x. We are now about to get even more interesting. What we're going to do is factor out the GCF from only the first 2 terms. This might seem like a weird thing to do, but it's a common technique called grouping. The GCF of the first 2 terms is 2x, so let's go ahead and factor them out. Now, it may not be easy to see here, but if I put parentheses around the last 2 terms, you'll see that this entire statement has a binomial GFC. What we're going to do is factor out the entire binomial of x plus 2. It may help you to surround the entire statement with parentheses. Factoring out the x plus 2 gives us x plus 2 times 2x plus 1, which is the same as our original binomial product. It may be easy to think of x plus 2 as a variable. If you said x plus 2 equals y, then you could write 2x y plus y. And then factor out the y times 2x plus 1, which in turn equals x plus 2 times 2x plus 1. When you get more and more into math, sometimes it's easier to think of entire parts of equations as a variable. It's a technique called substitution that is used quite often in mathematics. Factoring these can get really tedious if you're new to algebra. But over time and through your courses through algebra and maybe calculus, you'll learn to work with factoring with ease. Let's go on to work out a couple examples. Number 1. 6x squared plus 25x plus 4. Our goal is to write this in the form of a binomial product. We're first going to find which factor of a times c sums up to b. So we know a times c is 6 times 4, which equals 24. The factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. The sums of these factors are 25 14, 11, and 10. The set of factors that sums up to a b term is 1 and 24. So let's go ahead and rewrite our equation. 6x squared plus x plus 24x plus 4. Now we're going to use our grouping technique twice, pulling up the GCF on the first two terms and on the second two terms each. X times 6x plus 1 plus 4 times 6x plus 1. The GCF of the first term is x, and the GCF of the second term is 4. We're now left with the binomial GCF that we can identify and factor out. 6x plus 1 times x plus 4. We can use FOIL to check our work. 6x squared plus 24x plus x plus 4, which simplifies to 6x squared plus 25x plus 4, which is our original equation. Number 2, 51x squared minus 5x minus 4. We have a trinomial with both b and c holding negative values. Since c is negative, one of the factors will be negative. And since b is negative, the larger valued factor will be negative. Finding the factors of a times c will be a bit harder. Just make sure you take your time and write out each factor. Now a times c equals 51 times negative 4, which equals negative 204. Since we know that only the larger factor will be negative, our factors are 1, negative 204, 2, negative 102, 3, and negative 68, 4, and negative 51, 6, and negative 34, 12, and negative 17. The sums of these sets of factors are negative 203, negative 100, negative 65, negative 47, negative 28, and negative 5. Our final set of factors gives the correct sum, so we rewrite our trinomial with the split middle term. 51x squared plus 12x minus 17x minus 4. The GCF of the first two sets of terms is 3x, and the GCF of the second set of terms is negative 1. Factoring out the GCFs gives us 3x times 17x plus 4 minus 17x plus 4. That sign can mess you up. Make sure you pay attention that when you factor out that negative 1, both these terms become positive. Factoring out a binomial factor leaves us with 17x plus 4 times 3x minus 1. This marks the halfway point through our study of factoring polynomials. Our next lesson will be a bit different. We're going to learn that not every polynomial can be factored with the techniques that we have on hand. We're then going to do the big math thing. We're going to learn our first theorem.